What will the reading be on the voltmeter in circuit 1 if each cell can supply 4 volts? Adding cells in series causes the voltage to be added. What do I mean? Each cell has a voltage of 4 volts. That's how hard that cell can push. Now, if they are connected in series with one another, then they all push in the same direction. They all push together, and their push adds up. Their voltage, also called their potential difference, adds up. And so what would their entire push be, their entire voltage, their entire potential difference of this battery be? It would be 4 plus 4 plus 4, which equals 12 volts. We can call that voltage in, V in. That's the voltage that the battery gives to the charges that flow through the circuit. Remember that a cell or a battery gives energy to each group of charge. In this example, we have a 9-volt cell, so that means that as the charges move through the cell, each group of charge, we call it a coulomb of charge, each coulomb of moving charge gets 9 joules of electrical energy. That's why when they leave the positive terminal of the cell, they have 9 volts, 9 joules per coulomb. Then these charges move around the circuit. And when they come back into the cell again at the negative terminal, they have to have 0 volts. That means that they have to lose all their voltage as they move through the circuit. Where do they lose this voltage? They lose it through the resistors. Just as much voltage as they get must be lost. The voltage in, which means the voltage that the battery gives to the moving charge, must equal the voltage out. In other words, the voltage that the resistors take away from the charge. If there are 2 resistors, then that voltage is shared between the 2. In the example shown here, the voltage across one of the resistors is 6 volts and across the other is 3 volts. That means that as the charge moves through this resistor, 6 volts is lost away from the charges into the air. And as the charges move through this resistor, 3 volts is lost out of the moving charge into the air. 3 volts plus 6 volts equals 9 volt. The amount of voltage that the cell has given is equal to the amount of voltage that the 2 resistors together have lost. In this example, one resistor has double the resistance of the other. 2K is double as difficult as 1K. And so, the more difficult one takes double as much energy out as the easier one, because it's double as difficult. So as the charges have to struggle double as hard through the 2K resistor, it's double as difficult, so double as much energy goes out as they struggle. Whereas as they go through the 1K resistor, it's not as difficult, so they don't lose so much energy. Now let's look at our question. We see that the voltage in is 12 volts, and so the voltage out also needs to be 12 volts, meaning that as the charges move through the bulbs are the resistors, as they move through the bulbs, they must lose 12 volt. They don't lose any voltage as they go through the ammeter. Why not? The ammeter has no resistance, 0 resistance. And so its resistance is like that of a good conductor. A good conductor does not lose any voltage as the charge moves through it. The same with an ammeter. No voltage is lost as the charge moves through the ammeter. So all 12 volts has to be lost through the 2 bulbs. By the way, the charge also does not move through the voltmeter because the voltmeter has infinite resistance, very, very high resistance. We say it doesn't really let any charge go through it. So it's only these 2 bulbs which are going to take out voltage out of the circuit. Now these 2 bulbs are identical to one another. They are exactly the same. And so they are just as greedy as one another for voltage. Or we could say they are just as difficult to go through as one another. So they will share the voltage equally between them. So we can see the voltage out must be 12 volts. There are 2 of them to share the voltage. Each one has to take 6 volts. So the voltmeter reading here will be 6 volts.